This is the hole cover that I've designed for the Festool TSC55 track saw. It's 3D printed in Anycubic Tough Resin Ultra with a much higher level of finish than you might get with filament or FDM printing. This level of finish better reflects the quality of the saw. Rather than looking like a 3D printed add-on, I wanted this to look like it was part of the saw from the beginning. The cover is also designed to fit into this channel in the cover plate, rather than extending beyond it. This keeps the lines cleaner and makes it look like it was designed to fit into the space, rather than looking like a patch of some kind. I think the result from this print is close to injection molding quality. If you use one of these Festool track saws, then you've probably wondered at some point, why did they leave this hole uncovered? Well, this hole is of course there so that you can remove the blade easily, and the Fast Fix system really does make blade removal quite easy. But I've heard owners complaining that leaving this hole uncovered makes the dust extraction less effective because you're basically creating a giant leak of air. Now that kind of makes sense, as you want to keep the dust extraction path as sealed as possible. And designing a 3D printed hole cover isn't that hard. It's a rectangle with a couple of hooks at either end, and you're done. Get on with your life, right? It's not that hard. But I wanted this to be a bit special, so I decided to develop this design further in resin. Well, what's the difference? It comes down to the difficulty of printing something that is flat, thin, geometric, and needs to be accurate to within about 0.1 of a millimeter. Now, you can of course do that with filament, but it looks like filament. And that's not all. You also need to design this for an opening that is, well, by Festool standards, quite rough actually. If you take a closer look at the opening, you can see that it looks laser cut or perhaps pressed out. I'm not really quite sure because the edge is so uneven. Laser cutting that I've done in the past looks a lot better than that. The thickness of the material also changes, which makes measuring the exact size of the opening more difficult than it needs to be. And if you compare the opening for the chip guard, you can see just how rough it is. The chip guard opening is beautifully finished and much easier to design for. So I started printing up some versions to see what sort of result I could achieve with resin. Now, I thought this was going to be easy, and I wasn't prepared for the errors. Printing on an angle seems to be the accepted wisdom. You can see with this one I've printed at 45, but I found that I was starting to lose squareness of the rectangle. Now, did I try lots of variations? Yes, I did. And here they all are. Now, I'm not going to go through all of these, but you can see that I tried just about every angle I could think of. Even the ones which I thought would fail, just so that I could see them fail, I printed them to convince myself that they would fail. And all the time I was focusing on avoiding placing the supports on the front face because I didn't want to leave those little support marks on the front. I wanted that surface to be as clean as possible. More attempts, so many fails. So many fails again and again and again. I also changed the design to add more material to give a higher chance of success keeping the edges straight while still having enough flexibility to install and remove this cover. Getting the print supported on the build plate was a continuous challenge. But then I thought, well, what if I use those support marks to my advantage? Well, that turned out to be the solution. But first I'll quickly talk about why this product needs toughened resin. Since it's a clip-in or a pop-in and out design, the tolerances need to be very fine. There needs to be just enough room for the cover to move so that you can get it in and out, but not too much so that it becomes loose and janky. Standard resins can be quite brittle, as you can see here. And working with fine tolerances like this, the resin tends to chip and break, and the corners are also more prone to snapping off, so yeah, that's no good. But when I started using toughened resins, and was daring enough to place supports on the front face, things started to improve. Placing supports on the front meant that I needed to use a finishing process to remove them after the print. Now, as it happens, resin actually sands very well. The combination of 3 different grades of wet and dry works well to remove the support marks and leave a super smooth finish. There's only one compromise, and that's that the support marks on the back and on one of the hooked edges are very impractical to remove, but that's okay because they don't affect the function or the appearance. This is Anycubic Tough Resin Ultra in black, which I reckon looks pretty slick. It's thicker than the other tough resins by Anycubic, but it's still easy to print with. The supports come off easily and seem to flex a bit more as you pull them off, which makes the whole cleaning up process easier. I've also noticed that I get less problems with edges and corners losing their squareness. In this design, I've actually added material into the product which gets sanded away as part of the support removal process. And that's so that what I'm left with is as close to square and straight as possible. This would be so much easier, I think, if it was injection molded. But hey, like I said, this is really close. And the tough resin means that it doesn't chip when you install and remove it. In fact, let's do that right now. So satisfying. But of course that might depend on how often you change your blade. I don't change mine that much, but let's say you changed it once a month for a year. That's 12 installs. Let's see if that works. Now, popping this thing in and out 12 times seems to work just fine without any visible signs of chipping or damage, and the cover still seems to sit well after all that action. It still looks like a tight enough fit. I haven't fully tested the capabilities of Tough Resin Ultra yet, but so far it's looking like a seriously tough resin which could be used for all kinds of things. Just take a look at this. This resin is really tough. That is, the ability to withstand this kind of bending and twisting without cracking is something I've never seen before in a resin. The first generation of Anycubic Tough Resin really impressed me, but this is something else. I'll definitely be doing more testing on this resin. Stay tuned for that. But this is ideal for clipping in and out of this metal plate of the saw. Even in this vise test, I was expecting to see it crack, but it simply just popped out of the vise, just like a spring. But does covering the hole actually improve dust collection? This is a test cut through MDF without using the hole cover. You can see that the extraction works quite well as designed. Festool do a great job of controlling dust with all of their tools, at least the ones I've used so far. Now you can see some dust here, but that's to be expected. And I'd say for a cut like this through 25mm MDF, it's doing quite well. But here's the same cut with the cover attached. When I look at the footage of the same cut with the cover on, I'm not really sure that I can see that much difference. Yeah, so that's a dud. Lots of time spent designing a solution for something that may have already been working at optimum level. Am I missing something? Well, maybe, because the people at Festool are pretty clever, right? Let's look at that side by side. You know, if someone told me that one of these was giving off less dust, I reckon I'd have to take a guess. Maybe, just maybe, there's a marginal gain. It really does kind of make you wonder, why I didn't just try this with prototype number 1 out of PLA and then decide whether it was going to be worth going to all of this trouble? That's a great question. And here's the answer. I wanted to make a product, and I wanted to explore this as a way of getting better at designing and printing with resin. Even though it's a small and simple shape, it's actually quite difficult to get right. And, well, all of these test prints are here to tell that story. But I can say this. I think it makes the saw look finished. And I think the black looks very cool. Rather than trying to match the Festool green, I thought I'd go with the existing parts of the saw, which are also black, or nearly black. And there you have it. The hole is now covered, and it looks good. Almost as if it was there from the factory. Well, I like to think so. You might think otherwise. Let me know in the comments. Anyway, I hope you got value out of that. And if you did, there's some information in the description if you'd like to know more about how to get one to make your saw look cool as well, and some links to the resin I used for this print. Thank you so much for watching. If you do like the design, then it would be great if you could hit that like button, leave a comment, and consider subscribing. And we'll see you in the next one. Was it worth it? No. 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 Ooh. No. Was it worth it? No. Yeah. Yeah, it was worth it. Yes, it was worth it.